Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your edible oil, fats and waxes. Okay, so in this lecture, what should we are going to do? We are going to discuss about the introduction part. Okay, introduction part. So we are going to discuss about the introduction of the edible oil, fats and waxes. Okay, so in this lecture, what should we are going to do? We are discuss about all these things. Then after that, in the next lecture, we are going to discuss about the physical properties of this triglycerides, chemical properties, and many more things. Okay. So first of all, before starting the lecture, we have to know that what does this means that, and what is the definition of this edible oil? Then what is the fat, and what is the waxes. Okay, so edible oil is called a cooking oil, and it is defined as a cooking oil or a edible oil is what? It is a plant or animal liquid fat which is used for frying. Okay, when we have to frying something, then we use this cooking oil or a edible oil, and it either it can be derived from a plant source or either it can be derived from a liquid source. This is called your this is called your edible oil or a cooking oil. Now the next is your fat. Okay, so fat are what? Simply, we all know that fat is a nutrient. It is what? It is a nutrient. And which type of nutrient? It is a macronutrients, which means that it's required in a large amount, and it provide the calories to the human being. Calories to the human being. We all know that beings, we all know that for the work we required our energy. Okay, if we want to do something, suppose that when you go to the colleges and attend the class, how you attend the class if you don't have any energy? So energy is required for doing the work, for doing the work. Okay, so this energy will get from a fat is a good source of the energy. Okay, and it is also a major part of the human diet along with the protein and fat. Major diet along with the protein and carbohydrate. Okay, so this is about the fat. Now the next is your waxes. Waxes are simply defined as a, it is what? It is a type of lipid which are made up of long chain fatty acid and alcohol. Long chain fatty acids and alcohol. So we are going to discuss about all these things in today's lecture. So let's start today's lecture. First of all, we are going to see the introduction part. Okay, we all know that either it is a fat, either it is a oil, or either it is a waxes. They are what? They are a naturally occurring ester of long straight chain carboxylic acids. Okay, so fats, oil, waxes. These three are what? They are a natural occurring esters. Okay, natural occurring esters, and it is a long straight chain of carboxylic acid. they also belong to the group of saponifiable group of lipids. Okay, they belongs to the saponifiable group of lipids, and these lipids are what they are a biologically produced material which are relatively insoluble in water but soluble in organic solvent. Now these lipids, okay, they secrete as some biological materials, and this biological materials secreted by the lipids, okay, and they are insoluble in water but they are soluble in organic solvent. Now which type of organic solvents? Organic solvents like your benzene, chloroform, acetone, ether, etc. Okay. Now, this saponifiable lipids also contain a ester group, and it also react with the hot sodium hydroxide solution and undergoing a hydrolysis, that is your saponification. Okay, due to the presence of this ester group, it react with the hot sodium hydroxide and undergo a hydrolysis, that is called a saponification. Now the next is your C. This is your lipid. Now, this lipid, one is what, in which no ester group are present. When there is no um, ester group are present, then there is a no reaction takes place, and they are what, they are a unsaponifiable. Okay. Okay. Now the example of lipid in which no ester groups are present, like your steroids, prostaglandins, and leukotrienes. Okay. Now when there is a saponifiable group are present, when there is a ester group are present, just a minute, when there is a ester group are present, then it will react with a hot sodium hydroxide solution and undergo a hydrolysis reaction, that is your saponifiable. Now the example in which lipid contain a ester groups are oil, fat, waxes, and phospholipids. So again, this will be discussed. Oil, fats, and waxes. Okay. Now the next is your saponification. Now, what does this saponification reaction means that? Saponification reaction means that. Now we all know that this is what, this is your chemical reaction. Okay. Just a minute. This is what, this is your chemical process in which there is a ester which are heated with a aqueous alkali. Okay, suppose that we have a ester, and this ester are with a aqueous alkali, that is your sodium hydroxide. Then two product we got, one is your alcohol and one is your sodium salt of the acid. Sodium salt, sodium salt of the acid. Okay, which is corresponding to the ester, and this sodium salt form is called soap. Okay, this sodium salt which is form, it is called what? It is called a soap, and the whole reaction is called a saponification. Saponification. Okay, now it is clear saponification is what? When a ester are treated with a hot or heat or hot aqueous alkali, that is your sodium hydroxide, and there are two products are formed. One is your alcohol and one is your sodium salt of the acid, and this sodium salt are what they are called a soap, and the whole reaction is called a saponification. Now the next is your, see, this is your reaction of saponification. Okay, this is your ester group. Then here it is react with the NaOH, and here OH is react with this, and here one of alcohol are formed, and one of alcohol group are formed, and one of sodium salt are formed. And this reaction is called what? It is called a saponification reaction. Okay, now the next is your fats, oils are esters of glycerol. Okay, fats and oil are what? They are the ester of the glycerol, and they are a simplest triol. That is your trialcohol. Now, in which each of the three hydroxy group has been converted to an ester. Okay, so in this reaction, when there is a trialcohol, now this trialcohol contain a um, 3-hydroxyl group. Okay, if it is a trial alcohol, then it will contain a 3-hydroxyl group. That is your OH, OH, and OH. Now these hydroxyl group are converted into a ester. The acid portion of the ester linkage usually contain an even number of carbon atom, which is unbranched chain of 12 to 24 carbon atom. Okay, so the acid portion of the ester, which is linkage, that is your fatty acid, they usually contain a even number of carbon atom. Okay, and this carbon atom are unbranched. Even number of carbon atom, and they are what? They are unbranched. Okay, and the carbon number is what? It is around 12 to 24 carbon atoms. Now, this triesters of glycerol, fats, and oil are known as a triglycerides. It is known as a triglyceride. The triesters of glycerol of fatty acids and oil are known as a triglyceride. Okay. Now, the next is your, this is your representation of the previous topic. This is your representation of the reaction. Representation of the reaction. Here it is a typical fat triester of the glycerol, and here it is a glycerol are formed. Okay. Now the next is your, there is a difference between a fat and an oil, merely one of the melting points. Okay. So if we differentiate the fats and oil, if we differentiate the fats and oil, then it will be differentiate on the basis of their melting point. Okay, we all know that this fats are what? They are solid in at room temperature. Okay, if we put the fat into a room temperature, then it will be a solid. Okay, and oils are liquid in room temperature. So this is the difference between the fats and oil on the basis of melting point. Both the classes of compounds are triglyceride. Now, as a glycerol is common to all fats and oil, whether animal or vegetable, it is the fatty acid part of the fat that is of interest. The difference among triglyceride, that is your fat and oil, are because of the length of the hydrocarbon chain of the acid and the number of position of the bonds, that is your unsaturation. Okay, so there is a difference between fat and oil, that is your triglyceride, and this is based on the length of the hydrocarbon chain, and along with it the number of position of the double bonds. Okay, how much double bonds are present and which position at this double bonds are present. Now the next is your the hydrocarbon chain of fatty acid may be completely saturated in case of a saturated fat, or may contain one or more double bonds. Okay, so the hydrocarbon chain which are present into a fatty acid, either they are saturated, or either it will contain a one or more double bond. The geometric configuration of the double bond in fats and oil is very normal, and it is called a cis. If the chain include more than one double bond, then this type of fat is called a polyunsaturated. Okay, if single double bond are present, that is called a unsaturated fatty acids, and if there is a more than one double bond are present, then this fat is called a polyunsaturated. The presence of double bond put a kink in a regular zigzag arrangement characteristic of saturated carbon. Because of this kink in the chain, the molecules cannot form a neat, compact lattice and tend to a coil. So, unsaturated triglyceride often melt below a room temperature, and thus they are classified as a oil. Now, the next is your there is a diagram which represent the unsaturated fat which are include cis double bond. Okay, here it is a king, poor packaging, and it will convert it into a oil. Fats and oil are the most concentrated source of energy. They provide approximately 9 kilocalorie of energy per gram. We all know that when we consume 1 gram of fat, then it will give a 9 kilocalorie of energy, which is compared to a protein and carbohydrate. That is, if we take a 1 gram of protein and carbohydrates, then it will give a 4 kilocalorie of energy. So that's why these fats and oil are the most concentrated source of energy as compared to this protein and carbohydrates. There are carriers of fat soluble vitamin and essential fatty acid. They also contribute to a food flavor and mouth feel, as well as to the sensation of the product richness. They are used as a frying fats or a cooking oil, where there is a role is to provide a controlled heat exchange medium, as well as it is also contribute to the color and flavor. Okay, they are also used in many other commercial application, which is include soap, detergent, emulsifier, printing ink, protecting coating, and feeds for our domesticated animals. Now the next is your waxes are what they are monoesters of the long chain fatty acid. Waxes are what? It is a long waxes are the monoesters of the long chain fatty acid, and it will contain around 24 to 28 carbon atom with a long chain fatty primary alcohol. A fatty alcohol has a primary alcohol group, that is CH2OH, which are attached to a 16 to 36 carbon atom long chain. These waxes are normally saturated and they are solid at room temperature. So this is a difference between this. Now the next is your Waxes ester of fatty acid and fatty alcohol. Now, the plant waxes are usually found on leaves or seeds. Okay, when the waxes are derived from a leaf, when our waxes are derived from a leaves, sorry, when the waxes are derived from a plant source, from a plant source, then they are usually derived from our leaves or seeds because it is present leaves or seeds. The cabbage of leaf wax, which consists of the primary alcohol, that is C12 to C18, C12 and C18 to C28, esterified with a palmitic acid and other acid. The dominant component are esterly and serially alcohol, that is your C26H53OH. This is what? This is your esteril and serial alcohol. In addition to primary alcohol, ester of secondary alcohol, for example, esters of non-icosane 15, all are present. Now, this is your representation of the previous reaction, that is your CH3. They have a single bond with a CH2 double bond, sorry, in bracket 13, which means that suppose that this is your CH3. Sorry, just a minute. CH3, then it is form a CH2, again CH2 for 13 times. Okay, then again here it is a CH, then again CH2 in bracket 13, then here it is CH3 and here it is OH. Okay, now the next is your, these waxes are classified are according to their origin. That is your, either it is a natural occurring or a synthetic. Okay, so these waxes are either natural occurring or either they are synthetic. The natural occurring waxes are again classified are on the basis of animal, vegetables and mineral waxes. Okay, either they are animal, vegetable or mineral. Okay, and beeswax, spermatic wool grease and linalool are the important animal waxes. Okay, the vegetable waxes like your caronoba, oricori and candelilla. Petroleum waxes are the most prominent mineral waxes. Paravaxin wax is a petroleum wax which consists normal alkane along with the molecular weight which are usually less than 450. Microcrystalline wax is also another type of the petroleum wax which contain a substantial amount of hydrocarbon other than a normal alkane, and the component also have a higher molecular weight than a paraffin wax component. Now, in the next table, here it is a composition of the significant commercial waxes which we get from a natural sources. So here the sources of the composition of the normal waxes. The first table show about the type of the waxes. Then the next table is for a melting point and then the main component. Okay, so the first type is your animal waxes. Animal waxes. Okay, So in the first one is your animal waxes, then a mineral waxes, okay, then a petroleum waxes, then your vegetable waxes. So here the four type. One is your animal, mineral, petroleum, and vegetable. Now the first one is your animal waxes, and the first one is your beeswax. Beeswax. The melting point of the beeswax is 64 degrees Celsius, and the main component is Merically palmitate. Merically palmitate. Okay. Now the second animal wax is a Chinese wax, whose melting point is 82 to 84 degrees Celsius, and the main component of the Chinese wax is isoheptacocele, isoheptacosonate, cereal lignocerate. Okay. Now the third animal wax is shellac wax, whose melting point is at the range of 81 to 82 degrees Celsius, and the main component is cereal lignocerate and cereal cerotate, and the last one is your cereal palmitate. And the and the next is your spermaceti, whose melting point is unknown, and the main component is your cetyl palmitate. And the next is your wool, which is anhydrous lanolin, whose melting point is 36 to 42 degree Celsius, and the main component is your polyester, estolytic ester, alcohol, ester of iso, and anti-iso acid. Now the next is your mineral waxes, in which the first one is your monton, whose melting point is 86 degrees Celsius, and the main component is tricontinyl ester of C28 to C30 acids. Okay. Now the next is your petroleum waxes, in which the first one is your microcrystalline, whose melting point is at the range of 71 to 88 degrees Celsius, and the main component is hydrocarbon, whose molecular weight is 490 to 800. Next is your paraffin, whose melting point is 54 to 57 degrees Celsius, and the main component is hydrocarbons, whose molecular weight is 350 to 420. Okay. Now the next is your vegetable waxes, in which the first type is your bayberry, whose melting point is 43 to 48 degrees Celsius, and the main component is your trimyristine and cristerine. Okay, now the next is your candelilla, whose melting point is at the range of 70 to 80 degrees Celsius, and the main component is C29 to 33 hydrocarbons, simple ester, and lactonose. Okay, now the next is your carnauba, whose melting point is 80 to 85 degrees Celsius, and the main component is ester of C26 to 30 alcohol and C26 to 30 hydroxy acid. Next is your esparto, whose melting point is 69 to 81 degrees Celsius, and the main component is hydrocarbon ester of C26 to 32 acid and alcohol. Then Japan, whose melting point is 51 to 62 degrees Celsius, and the main component is your tripalmetane. Then jojoba, a liquid wax, whose melting point is 11 to 12 degrees Celsius, and the main component is Ducosinyl ecosonate. Then uricuri, whose melting point is 79 to 85 degrees Celsius, and the main component is mercurial cerotate and the hydroxy cerotate. Then the last one is your sugarcane, whose melting point is at the range of 79 to 81 degrees Celsius, and the main component is mericylyl palmitate and trimetryl palmitate. So these are the source and the composition of the normal component along with their melting point. Now the next is your fatty acid. Okay, the carboxylic acid which are obtained from the hydrolysis of the fat or oil are called a fatty acid. Okay, when there is a hydrolysis of fat and oil, then we obtain a carboxylic acid, then it is called a fatty acid. They are a building block of the triglycerol, and the fat and oils are often named as a derivatives of these fatty acids. Okay, so they are what? They are the building block of the triglyceride. This fatty acid are the building block of the triglyceride. Building block of the triglycerides. And the fats and oil are also often named as a derivative of these fatty acids. For example, tristerate of the glycerol is named tristerine, and the tripalmitate of the glycerol is named tripalmitane. Now the next is your normal saturated fatty acid also have a long unbranched hydrocarbon chain which have a general formula CH3CH2 in bracket N COOH, and N is what? N is vary from a 2 to 24, and it is usually in a even. Now the next is your here it is the saturated fatty acid. Saturated fatty acid. Now the next is your unsaturated fatty acid. Unsaturated fatty acid means that which contain a double bond. If there is a single double bond present, then it is called a monounsaturated. And if there is a more than one dismethylene interrupted double bonds are present, then it is called a polyunsaturated. Now there are three system of nomenclature are used in the naming of the fatty acid. The first one is your trivial name or the common name method. The second is your the number of carbon atom present in the chain, and the last is your IUPAC system, that is your International Union of Pure and Applied Chemistry. The travel names indicate that the initial source of fatty acid are used more often than the IUPAC name in the industry. For example, butyric acid is a major component of the butter flavor. Palmitic acid come from a palm kernel, and the oleic acid are come from the olive. Okay, butyric acid come from a butter flavor, palmitic acid come from the palm kernel, and the oleic acid come from the olives. The number of carbon atom present in a chain which are followed by the colon, and the additional numbers which indicate the number of the double bond which are used as an abbreviation so that it will designated fatty acid. So if we have a 8 carbon series, that is your C18 ratio zeros, C18 ratio 1, C18 ratio 2, C18 ratio 3 respectively. Okay, so if C18 ratio 0, then it is your steric. If we have a C ratio 18 1, then it will be a oleic. C18 ratio 2, then it will be a linoleic. And C18 ratio 3, then it will be a linolenic. Linolenic, respectively. One or two letter abbreviation are also used, and these four acid sometime are designated by a ST, O, L, and LN. Okay, now the next is your this is a structure of the some fatty acid. The first one is your steric acid. Okay, here you can see that there is a saturated uh, group are present. There is no double bond. Okay, then the next is your oleic acid in which one mono unsaturated in which one double bond are present. Then the next is your linoleic acid in which one, two, two double bond are present, that is your polyunsaturated. Then linolenic, again it is a polyunsaturated. Then gamma linolenic acid, again it is what? It is a polyunsaturated, because here one, two, three double bond are present. Here one, two, three double bonds are present. And the last one is your arachidonic acid, which are important fatty acid for our animals. Here one, two, three, four double bond are present. Then it will also come under the category of the polyunsaturated fatty acids. Now the next is your, the IPSC name of the fatty acid is that of the alkane parent with the E change to a oic acid. The carboxylic carbon is SC. Okay, here it is your octane, then this is your octanoic acid. The suffix dioic is used if the acid contain two carboxylic groups. Okay, and the double bond in fatty acid are differ according to their number, location, geometrical configuration, and conjugation. This conjugation is a special case of location in which two double bonds are separated only by a single carbon-carbon bond, and the unsaturated fatty acid may have one or as many as six double bonds. Thus, it will contain a multiple double bond which are usually have a methylene group, that is your CH2, between the two double bond sequence. So the system is not a conjugated. Now the next is your, when there is a double bonds are present, then the suffix anoic is changed to a enoic, dienoic, or trienoic, which indicate that there is a number of bonds are present. The location of the first carbon in the double bond are also indicated by a number of preceding the IUPAC systematic name. The geometric configuration of double bond is indicated by a Latin prefixes cis, both hydrogen on one side and the trans, that is your hydrogen across from each other. If there is a unsaturation between the 9 and 10 carbon atom, then it will represent the cis orientation, which are the most common type of polyunsaturated fatty acid. Accordingly, oleic, linoleic, and the linolenic acid, which are called a 9-octane, sinoic, 912, octi, octadenoic, and 91215 octadecanoic acid respectively. So there are some example of the fatty acid and their sources, common name, and the systematic name. Okay, so many additional terms are used to distinguish between the unsaturated fatty acid by the location of the first double bond, which are relatively to the omega or CH3 carbon atom. Thus, this oleic acid are both, that is A9 and a C18 ratio 1 co9 acid. Linoleic acid A9-12 and C18 ratio 2 co6 linoleic acid is both A9-12-15 and C18 ratio 3, where 3 is what? It is a co-3 acid. Now the next is your, there is a some important fatty acid and their name and the common sources of it. So the first one is your carbon atoms. The first table is for a carbon atom, and the next table is what? It is a common name, and the third table is for the systematic name, and the last one is your common source. Okay, so the first table, the first thing is represent the saturated fatty acid, means that there is no double bond are present. Okay, so if there is three carbon atom, then it is called a propanoic. and the systematic name is propanoic, and the common source are bacterial fermentation. If there is a 4 carbon atom, then the common name is your butyric, and the systematic name is butanoic, and the common source is milk fat. If there is a 5 carbon atom, then the common name is valseric, and the systematic name is pentanoic, and the common source is bacterial fermentation. Okay. If there is a 5 carbon atom, then it is your uh, again it is called a isovaleric, and the systematic name is 3-methyl butanoic, and the common source are dolphin and the propice fat. Okay, if there is a 6 carbon atom, then it is your caproic, and the systematic name is hexanoic, and the common source is milk fat, some seeds oil. Okay, if there is a 8 carbon atom, then it is your caprilic. Okay, and the systematic name is octanoic, and the common source is milk fat, palm seed oil. Okay, if there is a 10 carbon number, then the common name is capric, and the systematic name is decanoic, and the common name is sheep and goat milk palm seed oil, sperm head oil. Okay, so if there is a 12 carbon atom, then it will be a lauric common name, and the systematic name is dodec dudaconoic. Okay, and the common source is coconut oil. If there is a 14 carbon number, then it is a meristic. A systematic name is tetradeconoic, and the common source is palm oil and coconut oil. Common name, if there is a 16 carbon atom, then common name is palmitic, and the systematic name is hexadecanoic, and the common source is palm oil. If there is a 18 carbon number, then the common name is steric, and the systematic name is octadecanoic, and the common source is animal fat. If the carbon number is 19, then it is tuberculosteric common name, and the systematic name is 10-methylsteric, and the common source is tubercle bacillus lipids. If there is a 20 carbon atom, then the common name is archidic, and the systematic name is ecosonic, and the common source is some animal fat. Then if there is a 20 carbon number, then it is a behenic. Systematic name is Ducasonic, and the common source is peanut and various other seed oil. If there is a carbon atom 24, then the common name is ligonoceric, and the systematic name is tetracosonoic, and the common source is minor amount in some seeds oil. If there is a carbon atom number 26, then it is cerotic, and the systematic name is hexacosonic, and the source is plant waxes. Carbon number 28, montanic. Systematic name is octasonic, and the sources is beeswax and other waxes. If there is a carbon number 13, then it is melisic, and the systematic name is Tria Contanoi, and the source is beeswax and other waxes. Okay, then after the unsaturated fatty acid, there is a saturated fatty acid. Okay, which means that there is a double bond. Okay, so in this case, if there is a 10 carbon number, then it is caproloic, and the systematic name is 9-decanoic, and the source is milk fat. If again 10 carbon number, then it is stellenizing, and the systematic name is 2,4-decadenoic, and the common source is stellengia oil. If there is a 12 carbon number, then it is laurolic, and the systematic name is 2-dodisonic, and the common source is butter fat. If there is a 18 carbon number, then it is a linoleic, and the systematic name is 9-12-15-octadecanoic, and the common source is linseed oil. So this is all about the some important fatty acid along with their name and common sources and their systematic name. Now the next is your glyceride. Now this glyceride, that is your glycerol, can be esterified commercially with one or two or three fatty acid with uh, produce mono, di or triglyceride. Fats and oils are also natural occurring triglyceride and it is distribution of which varies in different plant and animals. Here it is your glycerol, then it is a fatty acid treatment, then it will be converted into a fat with three different carboxylic acid and a triglycerides. The properties of the triglyceride are totally depend upon the fat composition of the fatty acid and on the relative location of the fatty acid on the glycerol. As a accurate method for determining the composition are available, there are several conventions have been developed to specify arrangement of the fatty acid on the glycerol molecule. Natural fats and oils are also designated as a triglyceride type in terms of saturated and unsaturated acid and isomeric form. Now, table 4.3, which are present in the next slide. This is about the triglyceride type and isomeric forms of some natural fat GS3 in the table, which refer the fully saturated glyceride, and GS2U, which refer the triglyceride composed of two saturated acid and one unsaturated acid. There is a distinction between 1, 3 and 2 position permit, which are identification of the SUS and SSU isomers of GSTU and the USU and the UUS isomers of the GSU2. So this is the table which represent the type of the triglyceride and isomeric form of the natural fat. Pig fat, peanut oil, beef fat, cocoa butter and soybean oil. Here it is the type percentage and here it is the isomers percentage per weight. A stereospecific numbering system, that is your SNN, is also used to indicate the location of the specific fatty acid in a triglyceride molecules, like 1 esteroyl, 2 oleoic, 3 myristoyl acid glycerol. The respective fatty acid are also indicate 1, 2 and 3 position, and this kind of information are very valuable, which are related to a properties of certain fats to a compositional data. So this is about the fatty acid composition of some edible oil and fats. So the some edible oils and fats like your almond oil, avocado oil, butter, canola, cocoa butter, coconut oil, corn oil, cottonseed, fish, lard, mustard seed, olive oil, palm kernel, peanut, rapeseed, rice bran, safflower, sesame oil, soybean oil, sunflower, tallow, walnut. Okay. Now the next is your, so summarized, there is a general distribution for the major edible fats and oil, which are represented in the next table, that is 4.5. That for the industrial fats and oils. Okay, so here the fatty acid is composition of some industrial oil, that is your castor oil, Chinese tallow, kraton oil, jojoba oil, linseed, rapeseed, seed, tongue seed, well seed. Okay, so this is all about the introduction of the edible oil, fat and waxes. In the next lecture, we are going to discuss about the physical properties, physical and the chemical properties of the triglyceride. I hope you will understand all the things which are related to today's topic. But if you have any query related to this topic, you can ask me in a comment box. Or for a further detail, you can follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn, and subscribe our channel on YouTube, that is ITLS Academy, and get our app from a Google Play. Or for a further query, you can ask your query to the helpline number that are already mentioned in your slide, that is 7080833 450 and visit our website www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.